bitches. Hello from your favorite artist electronist, Mr. Q12 here. Today I will present to you a small little experiment where I'm presenting a good MOSFET versus a bad MOSFET. And it's mostly a curiosity what I'm presenting here. Let me present the circuit first, and then we will do the experimentation. What I'm having here, I'm calling it a power line, although it's a bad name, but it is how I'm calling it. From here through this power resistor or resistor load resistor RL, here, this ceramic 100 ohms, 5 watts, through this MOSFET, which is this little guy here, as you can see it there, and you can see its diagram here. Its name is A09T, is a SMD component, and this is power supply 2, which is this one, and the 5 volts is coming through this plug here, and it's powering this circuit here. You see, drain, source, and back to the negative, exactly as it's showing here. You see, this is the circuit for this power supply 2. Power supply 1 here is this PWM that I'm having it here, and is this two alligator clips here, and is that one there. The only function is to drive the gate of the MOSFET here, gate, and through the source and back to the negative rail, and it is exactly doing this. This is the gate wire which is going there. You can see here, see gate, drain, and source. So that is the drain, and that's the source, and the gate through the source and back to this power negative rail, 0 volts rail of this other power supply. So I'm using two power supplies. Okay, clear as mud what I'm doing here. This is the good MOSFET, and this is the bad MOSFET. So first I will start testing the good one, and you will see the oscillogram and the voltages applied to it. Another parenthesis, if you don't have this fancy PWM generator, you can use whatever PWM generator circuit diagram you can find on internet. Until recently, I used this circuitry that you are seeing here on this paper, which is this in reality, and it worked fine, absolutely brilliant. Although this is a bit more versatile because I can go down to 1% and high to 99% or even 100. But this is a little bit limited from 10% to 90% or 88%. So it's a bit, but it is working for this purpose that we are for testing bad and good MOSFETs. It's good enough as it is, and even with 555, if you find the 555 circuitry, you can make it home, and you can reliably drive the large majority of the MOSFETs, I suppose. And the idea is that this PWM generator is powered with 10 volts, whatever it is. If it's this fancy one, or if it's this one you see here, plus 10 volts, I was powering as well. And if it's 555, also with 10 volts. And this one, this side, through the resistor and through the MOSFET with 5 volts from this guy here. All right, that's it. Let's start the experimentation and see what is what. All right, so now I will plug my ATX power supply that I'm having it here. And ta-da! Very nice, very cool oscillogram, and you can see this voltage maximum is 5.5 or 3, and is here. This is the maximum, and it's starting V minimum at negative under the 0 volts, and you see this is the marker for 0 volts, and it's a tiny little bit under it as it's showing there. And voltage peak to peak is from here to here, and this is 1 volts per division, so it's very easy to count. 1, 2, 3, 4, 5, and a little bit because it's that, and that's it. And it is corresponding this duty cycle 50% with what I'm feeding it here. So what we are seeing right now at the drain and the source, this oscillogram, the probes, these two probes from the oscilloscope are on the drain and on the source, and is catching this 5 volts from the power supply, and the 50% duty cycle from the PWM is also mirrored on this side with the drain and the source. So the PWM is actually on the gate, and the source here is switching, but we can see the switching perfectly on this side as well of the MOSFET. So that's my point of showing you all this data that is there. Okay, let me turn it off and change this good one with the bad one and see what surprises will offer us. So now I mounted this bad one, and we already can see that my oscilloscope is catching a little bit of the current fluctuations or the signal through the gate source, but is catching it in the drain source here. And if this was a better oscilloscope than this cheap one, Finersi, was probably also showing not so fluctuating values here, but is like 200 or 300 millivolts oscillation that he is catching, because this is damaged, is gapped, is having some issues. So right now this power supply is off, so nothing is circulating through this, but my probe is able to catch something, but it's catching from this side. Okay, and this, what it is catching right now, it is a leakage. So what you are seeing there, it is a leakage of the transistor, and it's not good. It's definitely not good. But this is one point. Let's see it when you actually run it and see the oscillogram and the voltages of it. So you see the oscillogram is way lower. You remember it was 5 volts, 1, 2, 3, 4, 5. So it was like this big last time, and now is almost half. Voltage peak to peak is 2.5, and before it was 5 volts. And here voltage maximum was here, but now is at 3.60. Here is at this line. Is the maximum voltage, and V minimum is at 1 volt. 1 volt over 0 volt line, so it's here, this entire line. And voltage peak to peak is actually from here to here, you see, and is not starting from 0 volts, it's starting way over it. I don't know why, but what is interesting is this voltage peak to peak that is way lower. Instead of the power supply voltage, which is 5 volts like it was before, and now it's showing half of it, 2.5. The 50% duty cycle is the same, so is nothing bad there, but the voltages are wrong. So this is the bad one, and is absolutely the same transistor, MOSFET transistor, with that one. Both of them are from the same package, but this one, the bad one, and let me close this because I don't want to overstress it more than it is. But I will actually I did throw it away, and I had to search it in the garbage bin to find it and to make the movie again. This is my garbage, this little box is my garbage bin actually. So this damage that you've seen is when I was using this you see 50 watts 1 ohm resistor, but now I'm testing with a much more safer 100 ohm 5 watts. When I was using that 1 ohm, I probably left it too much time in function, and they got overheated. I know for sure they are overheating very quickly, both the resistor and the transistor, but probably I left it too much time overheated like that. A couple of minutes it takes, 1 or 2 minutes. Usually I'm doing my experiments very quickly, less than 1 minute, especially for power stuff like this. But probably I was explaining things, and I got with the explanations and with my talking, and probably I left it a little bit more than the usual way that I'm experimenting with it, and probably a little bit more time it overstressed it. So this is a failure from temperature overstressing or over temperature. And this concludes this experiment. This was a very quick movie. This was a curiosity only to show you, to have an idea how a bad one compared with a good one is looking. This bad one is not completely busted, but definitely it must be changed. If you catch something similar like this, you catch it in a circuit, you test it like I did here, and you see this kind of result, you have to change it with a brand new one. What is very, very important when you are doing this kind of tests is to have a brand new one to compare it with, and ideally to have from the same marking, to be the same MOSFET, not something different. So to be the same MOSFET, but having a new one, and to compare the bad one with the new one and see the differences, exactly like I did here. In my experimentation that I did here, I didn't use this specific transistor that is bad here. I didn't use it in a circuit per se. I use it here in testing, and I know exactly what I did, that I overheated it. But in reality, who knows? In a circuit, it's a little bit more problematic to catch the real problem, why it got overstressed. This is it. This is all the experimentation that I wanted to show you. I hope you like it, and also leave a like and not leave dislikes anymore, motherfuckers. Yeah, thank you very much for watching, and see you later from your favorite artist electronist, Mr. Q12. I say you goodbye, bitches. Bye bye.